Good morning, gentlemen. We'll go ahead and get started. Carly's not with us today. She had another meeting, so she won't be hosting it today, but that's okay. Obviously, you guys have seen this, probably seen this screen here before, but I've got you guys on mute. If you have questions, just hit that raise hand. You can type your question in, and I'll try to get to it as soon as I can when I see it. And I may, if it's towards the end, I may just wait to the end of the training to answer those questions, but don't hesitate to ask any questions, and we'll go ahead and get started on the flow center information. There's me, little bald-headed guy there, working remote right now, as I'm sure a lot of you guys are. So I'm sitting here at my kitchen table, and hopefully my cat will leave me alone today. So basically, we have on our units, we have the source side water connections, and it's going to depend on the type of flow center, what different types of connections. Most of our units now, you guys are probably aware, we use the double O-ring fitting. There's some water-to-waters out there that don't, and a couple other units that don't, but the majority of them will use the 1-inch double O-ring fitting. And then the flow centers on the closed loop, basically the pressurized and the non-pressurized, the new ones that come out now, they're all double O-ring fitting. We do have some QT flow centers, the white flow centers out there in the field now from B&D, that those have the threaded or the swivel connection, like the hose connection on them. But all the others will more than likely need the hose kit. The hose kit is a 1-inch rubber hose. You can see it in the picture there. 10-foot max per unit, so 5 foot to the flow center from the unit and 5 foot back from the flow center back to the unit. On an open loop, we don't normally use a hose kit. We'll use a solenoid valve, either a solenoid valve with an end switch, which is a 3-wire valve, or a solenoid valve without an end switch, which is a 2-wire. We'll get in a little bit of the open loop wiring for the solenoid valves here and towards the end of the training today. With an open loop, you'd have to have a flow regulator or some type of flow meter to control that flow. And then regardless of whether you have a pressurized, non-pressurized, open loop, closed loop, always make sure you're putting PT ports in. Without pressure temperature ports, there's no way to check for flow. So if you call in tech support and we can't get flow, obviously flow is can affect everything else, your refrigerant circuit. So we've got to make sure that we've got proper water flow, and that's what the pressure temperature ports are for. So when in doubt, install a PT port. Pressurized versus non-pressurized, a lot of times it's just a matter of preference. They both will get the job done. I have a lot more experience with the pressurized, so I prefer pressurized, but there's a lot of guys out there that don't like the pressurized due to maybe air in the system or something, or they're just used to using it. And again, it's preference. It doesn't affect the way the unit is going to operate. So some of the advantages of the pressurized flow center is on the right side in that picture, the smaller of the two. There's less piping involved with the pressurized system. The flush ports and the valves are included on the flow center, although the new NP series, this black cabinet, it's got the 3-way valves on it as well. But if you happen to go with maybe QT flow center, it does not have those. But the new NP series with this composite or this black shell, it's they do have 3-way valves, so you can actually isolate the flow center from the loop field, and you can actually flush right at the flow center there. Installation of the valves is already included on the flow center itself, so that 3-way valve is insulated. So is the pump. So are the pumps. There's more flexible location for mounting of the flow center. You can actually mount that flow center on the side of the unit. Matter of fact, we sell a compact, or the YT unit, sorry, the packaged unit. We have it available with a flow center that does mount to the side of the one of the doors on the lower portion of the unit. You can order it with the flow center already with the unit itself. That's the only unit we have like that. We had one of our dealers, we have a round table each year with our dealers, and we asked them what they would like to see, and one of our dealers wanted the flow center already with the unit. So we do have that available on the YT unit. Some of the disadvantages of a pressurized system over a non-pressurized is obviously it's a pressurized system, so pressurization is critical. If you don't have pressure, the pumps will cavitate. You got to have, I think it's like 2 psi to prevent those pumps from cavitating. So in a pressurized system, the pressure in the loop field gives it that pressure so the pumps don't cavitate. In a non-pressurized system, it uses the standing column of water in that tank to provide the pressure so the pumps don't cavitate. Obviously, air removal is more critical. Either one of these flow centers or loop field, you're going to have to flush with a flush cart. The pumps on the flow centers are not big enough to flush all the air out. And regardless of it's pressurized or non-pressurized, you still have to flush the loop field on initial startup. There's a little bit of air in the system. It will work its way back in a non-pressurized and float to the top of this tank, and then escape through that cap on the top. But that's just micro bubbles or something, not big air pockets. Adding or removing fluid is more difficult in the pressurized. Obviously, with the non-pressurized, you can see the canister there. You can take the lid off or the cap off and just look down in there and see what the level is. You can also get a sample of fluid pretty easily. The pressurized, you got to use a PT needle and probably put some pressure on when you're pulling pressure out. So it can be a little bit more difficult. It's not impossible or anything like that. You just have to make sure you got the right tools with you. On a closed loop pressurized system, the loop static pressure will fluctuate with the seasons. So the pressure is going to be higher in the winter months than during the cooling season. Basically, why that is in the winter when the water is cold, 30, 40 degrees, it's going to cause that pipe to shrink. It constricts when it's cold. So as it constricts, it pushes on that water and creates higher pressure. In the summer, when you got water temperatures of 90 degrees, it causes that pipe to relax and expand a little bit, and then you can lose some pressure. If you have that issue, there are ways to fix it. We can use a pressure battery or a Geo-Prime tank, and we'll discuss those here in a few more minutes. But basically, then you don't have to worry about fluctuation of pressures in between the seasons. Again, those flow centers need, the pumps need 2 psi to prevent cavitation. If you ever I know a lot of times we go out to job sites and we're always touching lines and feeling temperatures and things. If you ever walk up to a flow center pump and it's super hot, more than likely that's due to air. It's either air or there's debris and the pump's not getting cool by the water that's in the system. So just keep that in mind. We have fixed speed pressurized flow centers. We have 1 pump, 2 pump, 3 pump, 4 pump flow centers, just depending on the size of the unit. Usually a 1 pump will go up to about 4 tons, obviously depending on the length of their loop field, but usually it's right about 4 tons. We usually got to step it up to a 2 pump right about 5 ton. And that usually the 2 pump is usually pretty good for about up to maybe 7 tons or so. And then I'll go up, maybe 7 to 10, maybe a 3 pumper, and then anything over probably 10 ton would be, if you had a fixed speed pressurized flow center, it would be probably a 4 pump. Again, we use double O-ring. There are the double O-ring fittings on the left, the double O-ring fitting to the unit, so that would be a hose barb. And then on the right, those are actually the fittings for the loop field, the PE pipe, the HDPE pipe there. The flow centers, they're black now, not white like this, but they look other than the color, they're the same. You've got your 3-way valve, it's got a foamed cabinet on the back. One thing I will say about flow centers, especially pressurized flow centers when they're new, you get someone or you have one that's leaking right off the bat. A lot of times what I see is it's when the loop field piping comes in the top, which it doesn't really matter. You can turn these flow centers whichever way you need to, but I see that the loop field pipes don't come in straight. You know, maybe one of them's like kicked off just a tiny bit and it doesn't want to seal right. And what happens is that water will actually come out the top and run through the back, and it'll look like the flow center is leaking because you can't see it leaking from anywhere else, just back behind that foam. And I just say, just be real careful and have and double check to make sure that the seals are sealing properly and that they're in there straight. I've just seen a lot of flow centers come back and they're not leaking when they come back here. And it's normally on a brand new install. So make sure also there's a little packet of grease that comes with these flow centers. Make sure you're putting a little bit of that grease on those double O-ring fittings. For one, it'll slide into that connector a lot easier, and you won't roll those gaskets or pinch them or, you know, put a crack in it or something like that. So, and if for some reason it doesn't come with grease, you can use like a water-soluble grease that you can purchase at CVS or Walgreens or something. We do have adapters for pretty much just about anything you need. We have, you know, the double O-ring by hose barb, male pipe thread, the PE socket for the loop side. We have hose barb, MPT fittings. So we pretty much got you covered on the fittings from the unit to the flow center. You get into the bigger units and you're going to use the FPT or the female pipe thread fittings, and the smaller units, probably up to maybe 6 ton or so, we'll use double O-ring fittings. Pressurized flow center mounting. Mount as close to the unit as possible. When we do pressure drop on our units, if you ever, you know, you need pressure drop for, you know, let's say a WTO 60, so you can size your pump. We factor in the heat exchanger, the piping that's in the unit, and also the 5 foot of hose kit, or the 10 foot, 5 foot each way. But we calculate that into our pressure drop. So when you're sizing a pump, so if you go larger, if you have a longer distance between your unit and the flow center, then you may want to put that into your calculation when you're sizing your pump. But we do put in there for 5 foot each way. Make sure that the pump shafts are always in the horizontal position, so parallel with the floor. Electrical box, make sure it's on the top. If you turn the flow center upside down and don't move the electrical box to the top, what will happen if they do condense and sweat? There's a lot of humidity in the building or something, or sometimes that water temperature is just the right temperature and it will sweat. Well, that water could actually run down and sit in the electrical box, and then it could fill up the electrical box and short out the connectors there. So if we have it on top, the water can't stay in that box. It'll run to the bottom and drop off the bottom of the pump. So make sure the electrical box is always on the top, no matter what position the flow center is in. Again, hose kit not to exceed 10 foot in total length, so 5 foot each way. you install it on a wall, you know, some studs or whatever, make sure that you put maybe a rubber pad or some cork backing or something. So if it has some vibration, and it will, I mean, I'm not saying it's going to have some major vibration, but it's a pump. So it's going to cause a little bit of vibration. And if you don't, it could actually transfer the sound of that vibration through the studs up into a room where they don't really want to hear it. So if you're going to mount it on the wall, make sure you're putting something behind it. You may want to do that. You can mount it to the side of the unit, and I would definitely put some pads in between the unit and the flow center as well. Make sure you always leave access on the side of the flow center so you can turn those valves. Let me go back to this picture here of this flow center. We see where that arrow's at. Well, if you stick it real close in a corner on a wall, you're not going to be able to get your ratchet in there to put that 3/8 drive into that hole and turn it. You may be able to get one in there, but then you got to get your head on the side to be able to see where those little notches are so you know it's open and closed. So make sure you've got a little bit of room there. It's always, I've seen a few where I've had to actually use a mirror and look at it and turn it and then look at it and turn it. Again, it can be done. It just makes it a lot easier to get it if you can stick your head back in there and look and see what you're doing. Make sure if we've got non-pressurized system that we're not, or pressurized system, sorry about that, we're not using PVC and we're not using PEX. PEX has a huge pressure drop on it. If you use it, make sure that you're running your calculation for your pressure drop using the PEX. I just don't recommend it. But no PVC on pressurized. Sooner or later, probably sooner than later, it will break, then you're gonna have a big mess. So no PVC. Make sure you're insulating all indoor loop piping. Loop temperatures are gonna get below 40 degrees more than likely. So just make sure you're insulating your indoor piping or it will sweat. Again, this is the a breakout of the three-way valve if you were to pull it out of that flow center. There are gaskets and a snap ring that can be replaced if the three-way valve is leaking. A lot of times you'll see a little bit of water coming out between that plastic and that brass piece dripping down the side of the flow center. That's an indication that those seals are leaking. If it's out of warranty, then you can get a gasket kit. It'll come with 3 gaskets and a new snap ring. So it can be repaired. Make sure you just take the snap ring off and then you'll put your 3/8 drive into that square hole and move it back and forth, and while you're kind of pulling out a little bit, and that whole piece will come out and it'll be those 3 gaskets, and you can replace just those 3 gaskets. And then make sure when you're putting it back in, it will come with some grease. You can put that grease on there, and that that insert will go in a lot easier. It's not a real easy thing to get it out because it's real tight. Obviously, there's a real fine clearance. So it's a little bit difficult to get out, but it definitely can be done. I've done it. So loop field connections to the flow center. Again, those are normally going to be your PE pipe. So it's going to be an 1.25" socket fusion fitting. And then again, at your flow center, more than likely, it's going to be these hose bar fittings. When you order your hose kit, you can order them with the PT, and it'll have a plug in where the PT goes. It'll come with the PTs. You have to put them into the fitting, but I would recommend that you just order the fittings with the PT port adapter fitting in it, or adapter in it, so that you don't have to put them in the pipe somewhere else. And to be honest, I don't care if the PT ports are at the flow center or they're at the unit. It doesn't really matter to me. Sometimes it's a little bit more difficult if you put them at the unit, because on a packaged unit, the water connections are underneath the return. So if you're a bigger guy, you know, tall, I'm not, or just older and you don't like getting underneath the return, then it may be easier to put it at the flow center. If you put it underneath the return, you kind of got to get on your hands and knees down in there, and it's a little dark area. So I'm a small guy, but I'm getting old, so I don't like to kneel down on that concrete floor. But sometimes you got to do what you got to do. I would recommend putting them at the flow center just for ease of checking things. But again, it doesn't really matter. Here's a couple double O-ring 90s. You can see the PT port connection on these. And then we also have the MPT bi-hose bar there with the PT port. Just wanted you to see that we do offer those fittings. We have straight and we have 90s that have the PT adapter on it. Wiring loop field, I know this picture is kind of fuzzy there, but don't hook the flow center pumps directly to the contactor. We see that quite a bit, mainly because those guys don't see this little pump block that's back behind those 7-amp fuses. Those 7-amp fuses are resettable unless you trip them more than too often, and then they will stick open. You have to replace it. But the pumps are protected by those 7-amp fuses. So your desuperheater pump connects here. If you've got a desuperheater, as well as your flow center pumps. If you had a water-to-water unit, the load pumps will go there as well. So this is where your flow center pumps will be wired into. For some reason, you hook them to a contactor, it's not the end of the world. Because that's basically the power to this pump block comes directly from the contactor over through the fuses and then to the pump block. You can mount, you can have one flow center with multiple units. If you've got like this pressurized flow center here, 2 units is the most you can do. And with this, you'd want to get the pump sharing module so that when one unit or the other is calling, the flow center will come on. This is basically just a setup for a single flow center with 2 units on the same loop field. This is the pump sharing module. So basically, when 2 units are connected to one loop flow center, it's basically, you can see you've got Y and C from unit A on the right there, and Y and C from unit B. And then you're going to have your line voltage coming in from one of the units. So that's 200 and 208, 230 volt from one of the units to power that control all the time, the high voltage. And then those relays, if one of those units is calling, will close and send the power to the pump on the flow center. So if either one is calling, the flow center runs. Now, let's say that unit A is the one that's supplying the high voltage to the pump sharing module. If unit A goes down and you're out there working on it, and you kill the high voltage power, and then the second unit faults out on flow, well, that's because it's lost the high voltage and it's not turning your flow center pump on. So if you're working on one, it could actually affect the other unit as well. So just keep that in mind, that if you do have this, that only the high voltage is only supplied from one of the units, not both of them. If you have 3 units and you want to tie them all into the same loop field, then you would have to have individual flow centers for each unit. Make sure that you are installing check valves at the flow centers and also shut-off valves. So if you need to isolate and change out a pump or something like that, but any more than 2 units, you have to get another flow center, basically. If you had, let's say you've got like 20 units, in a big building, I probably wouldn't do flow centers. I would probably do one standard, maybe variable speed pump in the whole building, and then have zone valves or whatever for each unit to call at that time to supply the flow on that. But you get into a bigger job like that, definitely get with your TM or tech support. We can give you a hand on how your best way of flowing water for those systems are. This is a pressure battery. Basically, the pressure battery is like an expansion tank. It's a PE pipe, basically, and it's got a standard socket fusion fitting. It's got basically a rubber bladder inside of there and some retaining screws. It's not really field serviceable, so you can't really, if something were to happen to it, you can't fix it in the field. But basically, the pressure battery, it allows up to a 6-ton loop to expand without creating a flat loop or significant loss in pressure. Sometimes you run into systems where you have a large pressure difference in between summer and winter. And so, in the winter, you got high pressure, and in the summer, they're having to go out there and goose it back up. This will eliminate the need to do that. You can basically install it anywhere in the ground loop, and atmospheric pressure, or 14.7 roughly PSI, is held on the back side of the bladder, and it's got about 1/3 of a gallon of water. Basically, when the loop piping expands, the bladder pressure pushes the excess water into the loop piping. So it's just kind of like an expansion tank. Geo Boost, which if you're dropping pressure and you're out there a couple times a year to boost it back up, more than likely it's got a small leak somewhere. It's one thing if you can look in a basement or crawl space or something for some pipe that's leaking, but if it's not leaking anywhere where you can get to it, it's in the ground somewhere, so it's not like you're going to dig up that ground and try to find it. It's not going to happen. Obviously, if it's a huge leak, you got to do something about it. But if it takes 6 months to drop pressure or something, you can get what we call a Geo Booster, and it will maintain a set pressure of anywhere from 25 to 35 PSI. Basically, there's a little pump inside of here, a little black pump in the lower right corner, and it's got a tube that will run to basically you can put it directly into your source piping, or you can tie it into the PT port with a needle and a T, so you can still check your pressure drop. But it looks at pressure back to the pump, and once it drops below that pressure, it'll turn that pump on and drop some of that fluid that's in the reservoir into the system. Now, the system of this tank is about, a gallon or so. So it's not really a lot of fluid. And you think, well, it'll probably suck that dry pretty quick. Actually, when a pressurized system loses pressure, it normally doesn't lose a lot of volume of fluid. For one, once it does drop down to 0, then it won't really leak at all at that point, because there's no pressure pushing back on it. But a lot of times you lose pressure and not a lot of volume. So I know we've got a couple of these installed at different places throughout Greenville, and there's one over at the Catholic Church here in town that I've done a lot of work on, and I had to go out there maybe once a year and put fluid in it, but it was still at least half full. So it doesn't really use up a whole lot of fluid. What I'd like to do is get a mix of the antifreeze that they have in the system and put it in the tank. Obviously, don't put straight antifreeze in there. And then if you have some extra, just put a jug underneath it. Just set the jug underneath this Geo Boost and leave it. And like in this last picture here, you've got a sight glass, and if the antifreeze has the color to it, the homeowner can see that, and when it gets low, they can just fill it up. It's got a little cap, kind of like a gas cap on top, and they can open that. If the unit's running, it's not going to hurt anything. They can open it up and pour the fluid in, fill it back up. Makes it real simple for them. Again, if the system's running, the system's off, it's not going to matter either way. At that point, it's non-pressurized, so our that portion of the tank is. So if you open it up, it's not going to spray water and that kind of stuff everywhere. Basically, there's a little setup to the unit. To be honest, I don't really care where in the system you put it. I would normally put it in before the unit. So I may actually put it on the after the flow center, but before the unit, where you've already got a PT port. It's not going to hurt anything to put it there. So a Geo-Prime, basically a Geo-Prime turns a pressurized flow center into a non-pressurized flow center. So now this Geo-Prime tank is like your non-pressurized standing column of water. This will give it your pressure on the pump so they don't cavitate. And it's basically just a reservoir with a holding tank. Again, it's kind of got like the little gas cap, so it will bleed air out as air comes into this tank. And again, it's got a sight glass. The homeowner can fill it up when it gets low. Real simple way to turn it into a non-pressurized when you've got issues with a little bit of air in the system. Non-pressurized flow centers. So we use the NP series normally now. I think we can still get some others too, but this is the one we've been using. You can see those dotted lines on the left picture. That's your rubber hose kit. And we've also showing a three-way valve for, that's basically a flush block. So if you, obviously you're going to need to flush, so you'll probably need that three-way valve. It's an insulated flushing block is what that is. Basically how a non-pressurized flow center works, the flow drops into the top of the tank. There's any air in the tank, air in the water that comes back. The air will go to the top of the tank and be eliminated through that gas cap type cap. Then it actually sucks water out of the bottom of that tank. There's a dip tube, and it'll go up and through the pump, out through your valve, into the unit, and back through. There's your a little bit closer up view. That does have a double O-ring fitting from your loop field, and then a double O-ring fitting to your unit, with a couple other flow link or double O-ring fittings right above these three-way valves so that you can flush. So if you have the NP, you don't necessarily, you only would need the one flush block for the unit itself. So you basically, when we flushed a non-pressurized circuit, we'd never want to flush through the flow center itself. The flow center has PVC in it, and we run the risk of breaking that PVC. So we never flush through the unit or the flow center on a non-pressurized system. QT flow center is very similar, except it does not have any flush block or any three-way valves on it. So you have to isolate and flush at another location for it. But it's basically has swivel connectors, and we don't sell a whole lot of QTs any longer. We've got a pretty good relationship with GeoFlow, and that's who makes this NP series flow center, and also our pressurized flow centers as well. On a non-pressurized flow center, the NP series is actually pretty good about, if you check pressure drop, it's pretty close to the actual flow. When we had the QT flow centers, they were not real accurate on checking pressure drop with and flow. So you would need a flow meter tool. And this is option one for measuring the flow with the tool itself. Obviously, this is not going to really stay in the system. You're just basically pulling out of the flow center, going through the flow meter, and then dumping right back in to the top of that flow center. You can also install option 2 when you can leave it in the circuit, but I would never recommend leaving it in the circuit. You guys have probably seen boilers, sight glasses, and other sight glasses. Usually after about a year or so, you're not going to be able to read it. So it's best just to, once you set it, it's not going to change unless you lose a pump. So once you set it, you shouldn't have to really worry too much about the flow changing any. We do have variable speed in the pressurized and non-pressurized flow centers now. And then we also have a variable speed with a fixed speed as your backup. So if you need more flow, it'll turn on that second pump. Basically, again, you can see a 2-pump here on the left side, but it does have a factory mounted and wired pump controller. Has thermistors depending on the type of setup you want. You can have just the flow sensor, or you can have flow and temperature sensors. And again, we have pressurized and non-pressurized variable speed flow centers now. This is the UPC controller for the variable speed pump. You can't just get the variable speed pump by itself. You've got to have obviously something that's telling it to control. And on this, you can monitor, you can set it up to monitor flow, sensors, you can set it up for checking both. If you have both or all the sensors, so you have temperature sensors and flow sensors, you've got both, then the unit will actually tell you, or the controller will tell you what the heat of extraction or rejection is, and also output your flow in GPM and your entering and leaving water temperature. If you get it just for flow, it'll just run the controller just based on flow itself, so GPM. If you ever notice one of these controllers and you look at the heat of extraction, and the number that you calculate and the number that this controller calculates could be a little bit different. This controller does use the exact specific gravity for the type of antifreeze that you put in to the controller. So where we say, 485 is a good number for any time we're using antifreeze, well, propylene glycol is actually 483. So it will actually use the 483 calculation rather than the 485. And so your hand calculation could be a little bit off from what's on the screen. Not really too big of a deal unless you get outside of your parameters. Again, that's the variable speed panel mount. Installation. Again, this is just the easy options. This is how it comes from the factory, and that's just monitoring your flow. That's the 1B. And the 2A would have the flow meter and the thermistors on it. One thing I will tell you guys, that if you ever go out to the system and the controller is blank, it's not coming on, and obviously the pump's not going to run. If you need to get them heating or cooling, if you unplug the low voltage harness on a variable speed pump, the pump doesn't know what to do, so it runs at 100%. So that's a good fail-safe. I wish they would do that on the ECM blower motors, because it's never the motor that fails. It's always the module. And it seems that way on these flow centers, the pumps as well. Unless you hit them with a lot of air, then they're going to lock up. But normally it's the module. And so just unplug the low voltage, the pump will run 100%, and then we can get you a new controller or whatever you may need. If you ever do run into a situation where it does lose the screen, we do recommend, if that happens, we get some dirty power sometimes from the unit and on the low voltage side. So if that controller fails, we're going to send you a wall transformer so you can get your power off the wall and not the unit itself. Just keep that in mind if you ever have someone who's got a problem with the controller. and they're not using a wall transformer, let us know, and we'll get one from GeoFlow sent out to you under warranty. Connecting the flow center, this is a flow sensor. It's basically, make sure you put a little rubber hose piece in between the flow center and the flow sensor connector there. And basically the wiring is pretty simple, common to common, your Y2 to your Y2, ACC to A, and R to R. And that's when you're using a flow meter. If you're not going to use the flow meter, you're just going to base it on temperature, then you would wire it in a little bit different because you have sensors, and the sensors for the flow meter, they would just plug right in to it. And it's kind of confusing because it does say EWT, LWT on the far left, and that's actually where the Molex plug goes for the entering water flow meter, not the actual water temperature. The thermistors go into the EWT, LWT therms. That stands for thermistors. A little bit confusing, but not too bad. High voltage, the high voltage, the variable speed pump needs high voltage all the time. So it's going to come off your contactor on the inlet, your L1 and L2 on your contactor. If you've got a ECM blower motor, if it's a packaged unit, that's where the ECM blower motor wires in as well, is to the L1 and L2 side of that the contactor. So it has power all the time, and the pump will come on using the low voltage signal. So L is your L2, L1 in, and those 3 bars, I hope everybody knows what that means, but that's a grounding symbol. That should be a universal grounding symbol, but I've had guys hook up power from the L in the ground or the N in the ground and right on startup and short it out. So I haven't seen that in a long time. I think we've gotten our point across there, but I always like just to mention it. If you've got a 2-pump flow center, it's a little bit confusing here. I know it's got a few lines going on, but basically what you're going to do is run from the contactor to your variable speed pump, because we need power to it all the time. You're going to piggyback on from the variable speed pump and take that high voltage to the controller. The controller will then decide, and you're going to run the power from the controller to the fixed speed pump. The controller will decide when it sends power to that second pump. So don't just take it from the variable speed to the pump, to the fixed speed pump, or the fixed speed pump will run all the time. Let the controller decide if it needs to run that pump. We do have a video on the variable speed. We won't watch it today. I think actually Kern Wildhaber might have put this video together, and it's a little dry, but it's a pretty good video. So if you get a chance, we've got that YouTube channel. You can go to enertechusa.com and click on Enertech University. And when that Enertech University pops up, there'll be 2 little tabs. One will say curriculum and one will say online video library. Click on that online video library. That'll take you to our YouTube channel, and you can watch this video there. You can watch this training today there too, probably this afternoon. It'll be uploaded to our channel. All of our webinars are being uploaded there. Flushing loop field. I meant to put a picture of our new flush cart in there. We just got it. Matter of fact, I just signed one out or purchased one for tech support and training. So going forward, we'll have a new flush cart. We couldn't get the cart anymore. Went to a different type of cart, and I believe we're actually getting the flush carts from GeoFlow now. We're not going to make them ourselves. So hopefully, maybe even I may even squeeze it in next week just to make a real quick snippet on it, because I wanted to put that in there today. It's got a couple other nice features of draining it down and things that'll make it a little bit nicer for us. So going forward, we will have a slightly different flush cart. I think the tank's white on it. The pump is a little bit different, and some of the connections are a little bit different as well. I actually had to take a hand picture of it. I've been on GeoFlow for about 2 months to get me some documentation on it, and I haven't heard anything back. I would imagine due to the virus stuff going on. So, flushing a loop field. This is a pressurized flow center. The three-way valves on the flow center. We want to start by flushing the loop field first. So we're going to basically turn our three-way valves to isolate the unit from the loop field, and we're just going to run the water through and flush through the circuit. And depending on how big the loop field is, it's really hard to say how long it's going to take. It could take a couple hours, could take longer. Basically, your flush cart's going to tell you. You'll see air bubbles or the level will drop. So you'll know when it's time to wrap her up. After you flush the loop field, then you're going to switch over your three-way valves and flush just the unit, and it won't take very long to flush the unit, maybe 10, 15 minutes max. After you've flushed the unit, then you'll want to go ahead and add antifreeze to the unit, to the system. So make sure you've got on the discharge, on the return line coming back to the flush cart, hook a garden hose up to the fitting. There's a valve on the flush cart, and run it to a drain. Leave that valve closed for the time being, and open up your flow center, so where it's going out through your loop field, and you can add the antifreeze right to the flush cart. Obviously, you don't want to add too much or overflow, but you're going to have to add and then open up that drain and let some water come out. Add antifreeze and let it. Again, you're adding and draining. You should know roughly how much antifreeze you're going to have to put into the system before you even get to the job. So you're going to have to keep putting it in until all your containers are used up. So just keep draining and filling, and then let it mix for a little bit as well. After you get all your antifreeze in there, let it mix for a little bit, and then you're going to want to check your antifreeze level and see where you're at. Make sure you didn't add too much or not enough. Again, let it mix, let it flow through the system for a little bit, and then check with a hydrometer or a refractometer, or however you decide you want to check it. I know they make an electronic where you can just put a little drop on there and it'll spit out the answer for you. I think those are a little bit expensive. That's why I don't have one. I'm pretty comfortable with using a hydrometer, except for the fact that I have a tendency to break them because they're glass. But they also make refractometers for alcohol and glycol. The alcohol ones, you got to be a little bit careful with what you get, because we're not checking like drinking alcohol content. So they can be off or a little bit different. So just be careful if you're purchasing a refractometer. Here is a hydrometer. I'm not going to get real in depth on how to read these, but they can be a little bit difficult to read. You can see in this picture, this is alcohol based. So if we've got on this hydrometer, it's showing 9.0, and it's about halfway in between the 9.0 and the 8.0. what's kind of crazy on this is there's a hidden 9. So that's actually 990 and 980. So we're right in the middle of that. So we're really 985 is what the actual number that we're looking at, not 90. We're looking at 985. We're right in the middle of that 990 and the 980. I know, really confusing. That's why guys hate these hydrometers. But we would just look on 985 and follow that over, and that gives us our freeze protection. And so in this case, if we were at 995, we would actually be about 17.5 degrees on our freeze protection for methanol. So again, they can be a little bit confusing how to read. This is an alcohol. Alcohol is either methanol or ethanol, and then it's lighter than water, water being 1.0 on this chart. And you can't see it, but the propylene glycol would be on the top of the chart because it's heavier than water. So we would be at a number above 1. And with methanol or ethanol, we're below 1 because we're lighter than water. Then after you've got your antifreeze mixed and you've got the right amount in the system, then we'll do our pressurization, which is pretty simple if you've got a flush cart. Is basically you're going to close off one of the valves and you're going to deadhead that pump back to the flush cart and build pressure. Make sure you've got a pressure gauge into your PT port, because we don't want to get too much pressure in there. I would probably stick somewhere between 40 and 60 PSI. If when you deadhead the pump, you've got more than a 2-inch drop in your tank on your flush cart, you still got air in the system. You can also shut off your flush cart, and if it pushes back and overflows, then you know there's air in the system. Or if you see bubbles coming back when you shut off, now you may want to wait a few minutes before you look for those bubbles, but if bubbles come back when you've got the flush cart off, then you know that there's still air in the system as well. But a good indication is either a 2-inch drop when you deadhead the pump, because water does not compress. Air will, but water does not. So if there's air in it, when you deadhead the pump, it's going to push that air and it's going to drop the level in the cart. If you turn off the flush cart, that air can push back and it can overflow that cart. So those are 2 obvious indications of air in the system. Make sure we get all the air out, or you will burn up a pump. Remember, I was pretty new with Enertech, and you get sometimes guys on the phone, they question, what you're trying to tell them in tech support, and especially I was talking to an old plumber. I think 30 years is the magic number, because that's what I hear a lot. I've been doing this for 30 years. That's the magic number. Once you hit 30, you've got it down. But it was a plumber, and I was telling him, well, it sounds like you got air in the system because your pump has failed. And he said, I've been doing this for 30 years and I've never had air cause a pump failure. And it kind of made me think, okay, I haven't been doing it for 30 years, but then I'm like, no, I'm not listening to him. It is air in the system, and actually it was, and we got a new pump and got it taken care of. But yeah, 30 years is the magic number. I'm close to it. I'm about 25 or 26 years, so I'm almost there. Almost an expert. Again, pressurized up to about 60 PSI. If ever you need to pressurize a system without a flush cart, if you're out there servicing the equipment, you can use a loop goosing tool, and city water pressure will be, I know around here in Greenville, we have close to 60, if not more, water pressure. But really, as long as we have positive pressure leaving the unit, it's enough pressure in the loop field. We just don't want it to be in a negative pressure when it leaves the unit. And obviously, we've got to have some pressure so the pumps don't cavitate. So we could drop down to 20 PSI, 10 PSI. Probably really wouldn't want to see it a whole lot less than 10. but just know we have to have some pressure, and we don't want it to be above 100 psi, and obviously nothing below about 10 on a pressurized system. So I don't ever see them at 100. It's usually somewhere in that 40 to 60 range is what I see. Excuse me. Non-pressurized system, this is kind of a crazy little picture here, but on a non-pressurized, we do not want to flush through the flow center. We need to isolate it because, again, it does have PVC in it, and it has a possibility of breaking with too much pressure. So we're going to need that. It says optional 3-way valve, but we're probably going to need that. On the other side, we can hook it into the flow center and then close that valve off and just flush through the loop field. Antifreeze in the loop. Selecting antifreeze, that's normally what their kind of codes and that kind of thing, what they're looking at. Obviously, you have to look at toxicity and flammability, the thermal performance, the heat transfer and how thick it is, the viscosity, cost, corrosiveness, stability, convenience, and obviously codes. We add the antifreeze to prevent this system from freezing up. Coaxes are a little bit better about handling freezing. You get into the braze plate or the tube and shell, and those don't handle freezing very well. So we don't want the system to freeze up because it will cause major issues. Propylene glycol, it's a non-flammable. It's safe if it's spilled or accidentally consumed. It's a sugar-based antifreeze. So with heavy concentration of it, it's thick and it's hard to pump. So viscosity can be heavy. It does have good heat transfer until you get to a certain point. You're putting too much into the system, and then our heat transfer goes down. It's not as good as like a methanol or an alcohol, and bacterial growth is possible with propylene glycol. So we've got to really watch our percentages with our glycols. Too little and we have bacterial growth, too much and it's too hard to pump. So there's a fine window in there. Normally we want to keep the propylene glycol about 25 to 30%. Here is that propylene glycol bacteria issue we talked about. Anything of 25 to 30% is too strong for the bacteria to survive. If you do happen to get the bacteria in the system, and what that bacteria is, if you've ever seen like the clear slime on fittings or in the pipe itself, that's the bacteria itself. And it gets in the system by any kind of dirt or anything when you're installing the system. And then it'll just feed on that bacteria, on the sugar in the glycol and spread throughout the system. If you get it in the system, you can rinse it out with bleach for some time with the flush cart, and it should kill it all off. And then you're gonna have to drain it out and start over again with your antifreeze and your water. So try to keep your pipes sealed and clean when on a job site. I know Ed Davis and I we didn't have a glycol issue, but we had a dealer that, oh yeah, our pipes are clean and sealed and we flush and all this. And then we finally talked him into flushing again for us. And when he got done, there was a big handful of crap come out of the loop field. So when you are flushing, I would recommend using the bag filters, because I think in that situation we pulled out like there was some stripped wire and some plastic and a little bit of other stuff too that caught it in that filter sock on the flush cart. So I would highly recommend the filter bags. We offer 2 different filter bags, a 100 micron and a 1 micron bag. Both are washable and reusable, and they just hang over the discharge back or the return line back to the flush cart. and will catch any sand or debris that's in the system and not pump it back into the system. So they're super helpful. Here is the potential for microbial activity in a propylene glycol system. So anything 0 to 10% of a glycol concentration, and you've almost got a 100% chance that bacteria will grow. From 10 to 20%, it drops it to about 50% chance of that growth happening. 20 to 25% glycol, and you've got about a 10% chance of it growing. Anything above 25%, and you're good. But we don't want anything above 30% of glycol because it'll cause pumps to fail and your heat transfer will be poor. So glycol has a fine window with it. To be honest with you, any antifreeze does, because here we've got methanol or GTF. It's alcohol-based. It's a wood grain alcohol. It's toxic in its pure form. It does have good heat transfer because it's real light, low viscosity. It's non-corrosive, but it can be highly flammable. So anything above 25% could be flammable. Anything less than 25%, 25% and less, and then you're safe. You will have to pre-mix the antifreeze in the field. My recommendation is do it outside. If you do it inside in the basement, you got a gas water heater in there, you could cause, thermal event. Let's put it that way. You could cause a fire down there. And the thing about methanol and ethanol is it's like the Ricky Bobby fire, the invisible flame. So you're not going to see it when it's burning, and hopefully it's not on you. So just be really super careful with methanol and ethanol. You'll normally get it in a 50% solution, so it's flammable, and you're going to have to mix it in the field. So do it outside if at all possible. Ethanol or Procool, it's a grain alcohol. It's denatured, rendered unfit to drink. I wouldn't know, never drank it. I'm not going to start now. It's got good heat transfer. It's a little bit thicker because some of the additives that are put in it. It's highly flammable as well, but it's safe at about 25% or less. So again, if you got to mix it, do it outside if at all possible. Water qualities, we'll probably touch on this here in just a minute, but in every manual, we have this chart, and it will tell you what we will allow and what we won't. So if you have heat exchangers failing or lots of pumps failing, a lot of times we'll ask for a water sample. And this is what we're going to look at. The majority of the time, what we're really looking at when we bring it back to test, there's a couple different ways we can test the water, bringing it back to us. We have test kits that you can purchase from Fernox that you can test your water yourself. The test kits, I think they can do like 100 tests or something like that. But you can buy the kit, keep it on your truck, and test all the water. So you can test it yourself. You can send it in to me, and I'll test it with one of those kits. Or I can, if you have to have documentation, I have a lab that I can send it off to. It'll cost you about $130, and we do not mark that up. Whatever our cost is what we pass on to the dealer or the distributor. So I think our actual cost is $128. So that's more than likely what you will be charged if we have to send it off to a lab for documentation. We don't need that. I can test it. You can test it. Whoever, you can have your local lab test it. That's fine with me. If you want to test it and then discuss the results, give the TM a call or tech support or something, and we'll discuss it. But normally when we bring it back or those test kits, we test for the pH, ammonia, chlorides, iron, copper, ammonia. I think I might have already said that one. And we can also check for inhibitors. So we can actually, if we have a water sample from the home and a water sample from the loop field, we can compare the two and see if you've got inhibitors in your antifreeze. Inhibitors are used for like rust and saving the different metals and things in the system. So we like, most antifreezes have inhibitors in there. I would not recommend using RV antifreeze because it's not. So don't use RV antifreeze from the AutoZone or whatever. Measuring antifreeze levels, we kind of discussed that. Above the 1.0, 1.0 is straight water. So above the 1 would be propylene glycol, and below the 1 would be methanol or ethanol, alcohol-based. And we're trying to get normally about 15-degree freeze protection. We normally will design a loop for 30-degree lowest water temperatures on design days. But as you know, we have non-design days that we're going to drop that loop field. So we give it a 15-degree window from whatever our loop field is designed at for protection. So we go down to 15-degree freeze protection. So on propylene glycol, that number that we're going to look at is about 1.03, somewhere right about that. And then on our alcohol-based, you can see the two different, about 0.982 and 0.974, somewhere right around there. Again, it makes it real easy when you have a refractometer. That little blue area there's a little door, flip that up, put a drop on there, and then you just look through the sight glass. Now, I just had water on it. You can see with nothing on it, the whole screen is blue. I put just a regular drop of water from a water bottle, and obviously water freezes at 32, so you can see the line right there. That's also how you can calibrate this sight glass. It's got a little calibration screw on it. You just put a drop of distilled water on there, and it should go right to the 32-degree mark. But as you can see, it's got propylene glycol and ethylene glycol, and it'll tell you your freeze protection is based on the line level there. You need to figure out how many gallons of antifreeze are in the system. In the manual, every single manual, we will give you this chart. And it'll tell you if you got copper or PE pipe, how many gallons are per 100 feet. And that's per 100 feet, not 100, not 1 foot. It'll also list right below that chart how much is in the heat exchanger, how much is in the flush cart, and how much is in the hose kit. You're like, well, the flush cart's not going to stay in the system, and you are right about that, but it is in the system when we add the antifreeze. And we will lose that fluid, but we have to account for it. So you're going to be wasting a little bit of antifreeze, but it's really not that much antifreeze, so don't really worry about it too much. Basically, you know, if you've got this system here, you've got 1.25" PE pipe, you've got 200 feet in the header. We know we've got 3 vertical loops that are 3/4 inch pipe, PE pipe again at 400 feet. So we know what's in the unit, we know what's in the hose kit, we know what's in the flush cart. So if the unit has 1 gallon, the hose kit has 0.4 gallons, and the header pipe is 200 feet of 1.25", you got 1.25" pipe. We can actually look on that chart. I need to adjust this. Carly's done a little bit of rearranging and it kind of messed it up there, but it tells us that for PE pipe, 1.25", 7.5 gallons per 100 feet. So we have 200 feet. So multiply 7.5 times 2, that's 15 gallons of fluid in that pipe. So we know all our loop circuits are 3/4 inch, 400 feet each. So 400 times 3 is 1,200. So we've got 1,200 feet, and that 3/4 inch has 3 gallons per 100 feet. So we have 1,200 total feet times 3 gallons per 100 feet. Looks like it cut it off there. But that would be, what, 40 gallons or so? 36 gallons. So we know we have 36 gallons in our verticals. We've got 15 gallons in our header pipe, 1 gallon in the unit, 0.4 in the hose kit, and we'll use probably the 10-gallon number for the hose kit, or I'm sorry, for the flush cart. So we have a total of 62 gallons in the entire system. That's the total volume. So if we want to know, let's say we want to use a 20% methanol or 25% glycol, then we're going to take that number, that 62.4 gallons that we have for total, and multiply it by the percentage. So if we use 30%, multiply that 62.4 times 0.3. If we want to use 20%, we use 0.2, and so on. 25%, we use 0.25. We'll just use 30%, and that tells us 18.72 gallons of glycol is going to be needed. So you can go ahead and order that. Obviously, we don't have 0.72 gallons, so we order 19 gallons of glycol, and that'll get you covered. So you can actually figure out well before they get to the job of that flush cart how much antifreeze they need, how much they need to order. That was pretty simple. Open loop. Well water stays at a constant temperature. We're not using antifreeze. Basically, this would be considered a pump and dump. Some guys don't like that term, but that's what we're doing. We're pumping from somewhere and dumping it somewhere else. Recommended flow rates, 1.5 to 2 GPM is recommended for open loops. So here we've got a 4-ton part load, 6 GPM, so 2/3 capacity, and full load. Again, here's a 4-ton unit, and they're using the 2 GPM per ton for their for this chart here. You will notice that there's 3 different flow rates listed in the chart. So we have recommended open loop flow rate on the first one. The second is flow rate, minimum flow rate for a closed loop, which is 2.25 GPM per ton, and recommended flow rate on a closed loop, which is 3 GPM per ton. Open loop, these are the components that we're going to be using on an open loop system. We don't just want to run water through the system all the time. You're going to be wasting a lot of water. You could deplete your well. So make sure we have a shutoff valve after your well pump. Always put a strainer in so we can collect any sand or debris before it gets to the unit. Make sure we're putting a shutoff there as well so we can isolate and clean out that strainer. Make sure you're putting pressure temperature ports in on the in and the out. Again, put a boiler drain on the outlet so that we can clean that heat exchanger. Over time, it will scale up, and there's a calculation we can do to figure that out. And then we can, once we know that it's dirty, we can actually clean it out through those boiler drains. You'll have solenoid valves. If you've got a 2-stage unit, then you'll more than likely have 2, one for first stage, one for second stage. Then you'll have some flow restrictors or flow regulators. You'll order those for the specific size of the unit. And then make sure you got a ball valve on the unit, on the discharge as well, again, so we can isolate some stuff. So how does an open loop work? Basically a Y1 call. is going to open up the Y1 solenoid valve, send that Y1 water flow through. When second stage is energized, Y1 will still be energized, so that solenoid valve is going to be open, and the second one will be open. So then you'll get your total flow back to the system with both solenoid valves open. So on a 048 and part load, we're going to be running roughly 6 GPM. You can actually go a little bit less than that. And then normally we're running in first stage, we're running 2/3 capacity. So we want 2/3 of the flow in going through your first solenoid valve and flow restrictor. So you get a 6 GPM flow restrictor for first stage and a 2 GPM flow restrictor for your second stage. So when they're both open, we output 8 GPM. Now we get into a 2-ton or less, it's probably just going to be best just to put one solenoid valve and one flow restrictor in and be done with it. We don't have 1 GPM flow restrictors. We only have 2 through 10, I think, or somewhere in there. I know 2 is the lowest. So we really can't do a 1 GPM flow regulator. So we start getting into a 2-ton unit or a 1-ton or a 1/2 ton. Just use one flow restrictor. You could also use circuit setters for flow if you've got multiple units and one well pump. You use solenoid valves and you could use some circuit setters. Water solenoid valves, we have fast acting, the original slow opening, closing valve, and the newer one, which I would not use either of the 2 on the left. I would only use the one on the right. It's got the end switch on it, so it'll send that Y1 call through the valve. Once the valve is open, it'll send it down to the unit. So that way we know that the valve is open before we're starting up the unit. And the valve is super reliable. It's got a little light on it, tell you whether it's open or closed. And we just don't have a whole lot of problems with them. And they do have a low CV rating on them as well, which is nice. So, and you can just replace the head. There's a little metal clip. You pull that metal clip and the head comes off. You can strap a new head right on there. I'm sure some of you guys have already used these. They've proven to be super reliable. They're not noisy, and we can use them for zone valving, for air handlers in a water circuit. We can also use them for the open loop. Open loop solenoids, we have on our units the YT-YU connection that normally will have a jumper. If you're using one with a solenoid with an end switch, remove that jumper, run your wire up, put a little piggyback on that. So once the valve is closed, it'll send power back through and back down to your lockout board. If you're using a valve without an end switch, then you'll want to use the terminal next to it, that A connection there for an open loop solenoid, no end switch. Try to use one with a end switch if at all possible. On an open loop system, always maintain water pressure in the heat exchanger by placing the controls, so those solenoid valves, on the outlet of the unit to prevent mineral precipitation. Basically what will happen is if we were to put the valves on the inlet, when the valve goes to shut off, all the water would drain out of the heat exchanger, and there would be some residual water left hanging in there. And as it dries out, the minerals stick to the walls and cause poor heat transfer. So you have to clean the system more often. So make sure you're putting them on the outlet, so when the valve shut off, the heat exchanger stays full of water. It stays flooded. If you're going to use an expansion tank on an open loop, use a closed bladder type expansion tank to minimize mineral formation due to air exposure. If you've got a flow restrictor or a flow regulator in the system and it's bigger than what you really need, you can always use a valve, like a ball valve, to kind of balance the flow rate a little bit if you need to. Obviously, water quality is a large concern in an open loop and a closed loop system. You know, that's another reason we don't want to just run water through the system all the time. Is, you know, you could use up to about 12,000 gallons of water in a day if that pump just runs and runs and runs and runs and runs. So make sure you're always putting in the proper valves and things, and you're checking your water quality. Normally in open loop, we're going to put the cupronickel heat exchanger in there, and that's so we can clean it. We can use some acid-based cleaners to clean those deposits off, and that's why we use the cupronickel, is for the acid cleaning. It won't pit as bad. It's a little bit more robust. So you can use cupronickel heat exchanger on a closed loop. It's not going to hurt anything. It'll cost you a little bit more money, but I know, like in the WT water-to-water units, that's all we use in them now, mainly because there was an issue at one point with the copper heat exchangers, but the cupronickel is all we have in the WT unit now. So it doesn't hurt anything. It doesn't really have, the performance isn't any different on the units. So when in doubt, even if, you know, if we have a unit at the factory in stock and you need a unit and it's only cupronickel, don't let that hold you up because you're on a closed loop. Go ahead and go with it. It's not going to make the unit work any differently. Again, we kind of talked about the open loop water quality. pH is a big concern. You may want to check the dissolved solids in a well system. That's where I see it the most often. But again, ammonia is a big one. You see a lot more ammonia than we have in past years. You know, it's just slowly getting worse and worse throughout the whole country. And I think it's just the different fertilizers and things that they're using in the fields these days. But water quality is not getting any better. It's only getting worse. And, you know, I've heard guys tell me, well, no, that's good water, we drink it. Just because you drink it doesn't mean that it's good for our piping system. You know, it may be okay from the utility standpoint, but sometimes the piping just can't handle it. So on every job, I would check the water quality. It's really easy to do. And if you have bad water quality, it causes the heat exchanger to fail. More than likely, what's going to happen is the water is going to enter the refrigerant circuit and the unit's going to be scrapped out. So if it's a water quality issue, we can actually void the warranty. And we'd hate to have the homeowner have to pay for a new unit due to bad water. So before you install the unit, always check water quality, always. If you have a bad water quality, don't use the open loop. If you've got bad water quality, don't use it on a closed loop. Bring your water in from somewhere else. Just because it comes out of the tap does not mean it's good. So just be careful with your water. Always check it. Always, always, always. Again, over time, your heat exchanger is, especially on an open loop, a closed loop, it shouldn't. But on an open loop, it's going to scale up. You may have seen some scaling on water heaters sometimes in the old galvanized piping. It would look like this, like a clogged artery. It shouldn't look that bad. If it does look that bad, you're going to have to replace the piping, but because you'll never get that cleared up. But we do have the ability to clean them out and flush it out every once in a while. And that's why we put boiler drains on an open loop system. So that's basically what I have for today. If you've got any questions, let me know. Shoot me an email if you guys have any training requests, or give us a call. And I think Tuesday I have TXV troubleshooting, and then on Tuesday I have superheat and subcooling calculations, and on Wednesday solar, and Thursday product install. And then the week after that I've got TXV troubleshooting and compressor troubleshooting, as well as solar sandwiched in the middle of that. So just a little heads up on some of the trainings that are coming up. And then we'll kind of see where we're at. That'll be towards May 1st, so maybe we'll be open again as far as getting back to normal, and we can get back out and maybe do some in-person trainings. I know I've got to get one scheduled for Austin, Texas for an on-site, and we had a couple more that we had to cancel, so I'm sure they'll be wanting to catch back up. But definitely, any UTMs, push your dealers to our trainings. I am giving out certificates. If you attend and you need NATE credits, I can get 1 or 2 hours depending on the training if NATE credits are needed. So if you need NATE credits and you're a dealer or a technician, get a hold of your TM or shoot me an email and I'll get a certificate PDF of it for you and get it shipped, get it sent over to you electronically. So thanks again, everybody. I appreciate it, and have a wonderful day, and stay healthy out there.